Hey guys, today we're going to look at some C++ inheritance in the basics and some general things about how it works. This is not going to be all inclusive. I will reference some documentation where you can look further if you want to see more concepts, but after watching this, you should be able to understand the general concept and work it as you need to for your particular project. So we're going to start with Visual Studio, and we're just going to create an empty project. I'm going to use a cmake project. You don't have to, but I just want to kind of get used to it. So we're just going to call this inheritance demo. There we go. Go ahead and create that. Let it create, and we will get some basic files here, which we will go over briefly. Now note that I did check keep main project on the root level at the bottom there. So I've got everything on the root level in just one cmake that adds my executable. So we're good to go here to start programming the project is the point. So this kind of breaks a little bit of what we were doing before, because before we were using the terminal all the time. This time we're just going to let Visual Studio handle some of that for us. All right, very good. So we got our header here, and we got a CPP that's just the main. And if we go ahead and compile and run, then we should get a hello cmake telling us that it's all working. Now what we want to do here is just add a few new files. We're going to go add new file, and we're going to call this one. Well, let's think of an actual scenario. Usually people just call it base and derive, but let's think of a real life scenario so that people can relate it well. We're going to call this one being as a living being, or maybe we'll just call it living being. So we're going to kind of use like an animals and a person type example, but this could be anything. Say if you were doing furniture, you might have the very base be, I don't know, like a non-living being. Anyway, we're going to make a living being here, and we're going to make this header have pragma once, because that's good practice. And we're going to do class living being. And now basically what we want this class to encompass is the things that all living beings have. And in our particular thing, we're going to say that all living beings have hit points. Because maybe we're playing a game or something. And, you know, maybe we can just say these are public for now. Let's not make anything too confusing. There's public, private, and protected. We'll get into those later, but we're going to start with just leaving everything public because that makes this the most simple to explain. And we don't have a constructor here, so everything is just going to default construct. This should just be 0 initialized, but we can do that to make sure it initializes. So we don't really need an instantiation class here, or a file, but we're going to put one in here anyway. New file, living being.cpp, and just include living being. And that way, anything we specify here, like this in particular, has a place to actually compile. Okay, very good. Now we can go back to our H file, and we're going to add this living being. And then our main here, which is always going to have all the includes. So our whole project is going to keep getting piled up here as far as includes. But now we can do this. And what we can do here is we can just take a look at this. And for example, we can instantiate a living being. I'll just call it LB, and I'll just say living being hit points. Now, keep in mind this has nothing to do with here. So yeah, we'll get there. We'll get there. Of course, we can reference hit points here because it's all public. All right, very good. So we'll hit play here, and now we got us a living being with 0 HP because that's what it initialized to. But say, for example, we want to say, all right, I don't want users to be able to instantiate this class. I only want them to be able to use it to inherit from, and they have to make their own living beings, and they can use this to kind of help construct their class so they don't have to give every creature they make hit points over and over. They can just say inherit from a living being. And we could add anything in here too. We could add like hunger, or anything, just fullness, or needs food, or anything like that a living being might need. But to make sure that this doesn't just get instantiated, or well, maybe we'll say we have a name here. So let's go string, and we'll say species name. All right, very good. And it'll just start as something like unknown. So maybe we don't want to instantiate it with anything. Maybe we also want to say they have to pass in a species name. So we'll go, actually, let's go const char star species name. All right, very good. And then we'll make this, and then we can say species name. Oh, we got to include string here, so it actually knows what we're talking about. Species name equals species name. Okay, and now we don't want them to not be able to give it a name. We can just delete the default constructor. So now back to our little demo here. If we just try to instantiate this without giving it any of its constructor stuff, it's going to be a little confused because it says, hey, there's deleted function, about the default constructor. So what we got to do is give it the actual name here. Let's call this one a fly, or maybe we'll say housefly, the common housefly. And now we can push out more info here to our cout. So lb.species name, hit play here, and we have now a little more info. Living species name, housefly, HP 0. Very good. So that's all about deleting a constructor there. Now, what if we still want to go further with this and say, hey, never instantiate one of these on their own. You have to make something that inherits from living being. In that case, we need some virtual overrides. Because right now, while you can inherit from this, it doesn't do a whole lot special. So let's go ahead and just make a new file. And let's say we want to make, okay, so living beings, let's say we're going to make the human type. All right, let's just use that as a quick example. Sure, most of you understand humans, or maybe you don't. We'll be honest, I don't understand humans. All right, pragma once, and we're going to make a class called human, and then we're going to go public living being. It has to be public. You might think you can do private or protected here, but I'm pretty sure those don't work with inheritance. For example, if I do private, it should result in some kind of compiler error. So I'm just going to write the keywords here. And if we don't want people to be able to inherit from human, we can declare it final. And that means no further inheritance is allowed, because you can chain inheritance. For example, you could now make another class that inherits from human, and it would have all the stuff from both living being and human. And you could get kind of a cascade of effects that can make a lot of sense in certain hierarchies. But here we go. So now in our demo, we can say human, and now it's going to have a little bit of an error here. And call it human, but we do got to include it. And we got to include human here so that it builds here. And we got to include it here. Okay, now when we compile this, we should get an error, which you will see shortly here. And it'll say, attempting to reference a dereferenced function. It's because, once again, this is trying to use the default constructor, but this one, the one it's inheriting from, has a deleted default constructor. That's because we want to say, no matter what, you have to specify a species name anytime you're instantiating any sort of human being. So you can do this and control how the item is allowed to be created. Your compiler will just throw an error if you don't specify the things that you must specify. So maybe we want hit points to be 1 starting out. That would be fine, because 0 just seems a little low. All right, so what we have to do is we need to make a human constructor that also takes a const char star species name. Or we could make one, make a human constructor, and in it we can say, all right, let's call living being with the species type human. Or I guess it would be like Homo sapien in this case, but you get to the point. Let's go ahead and go include being. Nobody knows what we're talking about there. And we, of course, we got to do this public, which is an example of private not working there. And we still have one error, attempting to reference a deleted function. Once again, does not like this default constructor. Maybe it likes this. No, it doesn't. It doesn't like it. It's not going to like this because it's deleted here on the base. So it's not going to be allowed here either. We do have to still go const char star species type. So maybe this would be better as something else, like let's do a frog. I like the idea of doing a frog here. And now one thing that's really cool, something you may not know, is that when you're doing this project, you'll notice as I'm adding stuff and changing stuff, it is trying to keep up with the cmake file by automatically changing these names and everything. So rather than us having to switch back to our cmake every time when we create these new files using the functions here, but you can manually do it if you're doing it in a different way. And if you need to correct it, just go in here and correct these names. We're keeping it super simple here and letting it just be mostly default. All right, so let's hit play. Of course, we don't have human anymore. It's now frog, so we got to change that. And we still got the issue with the human here. It's now frog. Frog is going to be the variable name. And we're still trying to use a default constructor that doesn't exist here. So we got to give it a type. Let's say maybe tree. A tree frog. As you can see, it's still not too happy. And that's because we need to put this function in here. So usually it's going to have a little quick action that says, oh, we got to correct this, I think, or something here. All right, well, basically we want to make this function over in the CPP. And we want to say living bean, we want to call its base constructor. Oh, we don't do that here. You got to do this in a special way. Put it in this list over here, living bean parentheses species type, whatever you're passing in here. Then you can start your brackets, and boom, that will work. That'll now use the constructor, and you will get the right type, living bean species, tree, HP1. Okay, very good. So what about this frog type? Where did it go? Well, it turns out you can access that as well if you're doing it in this particular way. You can also, of course, set anything a frog might have. Let's just add something to the frog. Let's have a little fun here. Say maybe privately it has float jump power because it's a frog. And we will just by default initialize this to 1.0. Very good. But now, when we go back here, we can say cout, well, we're typing living bean here, but let's be a little more non-specific. Jump power. Now this one is specific. Frog dot jump power. However, it's not seeing it here because we made it private. So let's just bump it up to public for the moment. Make it simple. And now we get all those, except I did the formatting a lot different on this jump power. Okay, so you might be wondering, what is the point of this? There is a point of us forcing a constructor type whenever we're making a certain type. So anytime you're making a living bean, it's going to force you to give a name. You can make it have whatever you want or need. So if we look at more modern APIs, sometimes they do stuff like this, and they have you force maybe a struct that you have to fill out. So maybe you have to fill out like struct details. This is more relevant for things that have special API settings. Or maybe it would be info. So that way you have to instantiate and fill out the struct first and then pass it in. So we could do something like that. Like we could have this have the standard string species name, and rather than this coming in here, info, we can make it const, it's fine. And we would go living info, and we could say species name equals info dot species name. All right, let's fill this out properly. There we go. And that way, when you now make something, say a frog, you can no longer pass it as tree. First, you have to make a living bean info. This is kind of a weird thing. You don't see this too much. We'll just call it frog info. But this could be handy if you got a bunch of them and you don't want to keep instructing the info over and over. You could do something like this. Living bean info frog info, and then we'll go frog info dot button species name equals well, frog, of course, or no, we'll say tree. And I will show you in a moment here how to do even more. So we're going to pass this info in here, and it should be happy. Why is this not happy? Oh, because we have to take it here as well. Living bean info. Let's stick with our const. We can also stick with a reference if we want to make it a little more efficient. So we got to put the same thing in the CTT file and pass that over here. Now it should construct properly, assuming we have filled everything out. Looks like we need reference here and reference here, and const here, and now this should work. Apparently we made an error here. Okay, it says frog, illegal member, initialization living bean is not a base member. Okay, did we get something wrong here? It's very possible we did. It's possible that it might not like the reference. Let's dig in. There's a lot of things here, but it's probably just one very small thing. Looks like it's not getting created how we want. So we should get living bean info in there. Oh, I need, yeah, one of these semicolons at the end of the struct. That's important. We get all kinds of weird errors if you forget that. And there we go. We get a species, it's tree, hit points, jump power. Now, maybe we want to say that, like, how do we know it's a frog? Sure, we could hold frog for every frog, or we could just get the class name. So I'm going to show you a little trick there to just spit out the class name. So we know it's a frog. So we can go cout type, and we can go type ID frog dot name. And that will get us, this should say class frog. There we go. Type class frog, species tree, HP1. Now we can get a little trickier here and go further with the inheritance and say, well, first of all, this still allows just like living beings to be instantiated. Living, well, we'll just say being here, and we want a species name, and we'll call it ASDF, as this is kind of a broken function. Or actually, you know, that's right, we take living being info. So let's pass in frog info again. And there we go. Now we should be able to spit out all this info about the bean by just passing this in here. Of course, it's going to have the frog info. We could create an entire different struct for it, but I'm just being lazy here. So that's why I've given it the same info here. And you'll see here, it doesn't like jump power, naturally, because it's behind in the inheritance. So we'll play here. There we go. Type living bean. It's got everything else. But now, what if we want to say, look, you should never be able to instantiate a bean. You gotta inherit it somehow. That's when we come to pure virtual. Now, C++ doesn't have the inheritance keyword, so what you have to do is use pure virtual. And we can also do other things like start keeping unique IDs, because sometimes that is very important in your software. So what if we also want to say that this has a unique ID, and we'll just start it out as 0. But we know that anytime this becomes instantiated, we want it to have a new unique ID that's never been used before. I'm getting a little off track here. I just want to show you this unique ID thing because it's pretty cool. So what you can do is you can make a static in the CPP here, so this isn't visible to really anywhere in our software. Static, let's go with unsigned int and unique ID, or we'll say total ID, total unique ID count. So this particular variable is only going to be accessible here unless we do some extern magic in other files. So we don't want to do that. We want this to stay only here, and we're just going to say anytime a living being is instantiated, we're going to say that the unique ID of that being is going to be equal to whatever our total count is, and then we're going to plus it up. So this is a post increment. So we'll first gather this, whatever this is, which should start at 0. Let's go ahead and make sure it initializes with that sort of thing. We'll actually even specifically put a 0 in here. So the very first time this is built, it's going to initialize to 0. The very first one will grab 0. Then after, since this is a post increment, it'll become 1. And that way, if we ever query for total IDs, we will get the correct amount. It'll say 1, but the first one's going to have the ID 0. So a little bit of a programming 0-1 trippiness there. But if you were to say ++ on this side, then it will increment first and give the first item the ID of 1. Hope that makes sense. A little post and pre thing there that can be very relevant. So let's go ahead and just show that real quick. We want to say now the unique ID. Unique ID frog dot unique ID and indel. And then we're going to look at this living being unique ID, just this plain one. And I will break this being in a second and show you how to make it non-instantiatable. And as you can see, they now have unique IDs. The frog got 0, the living class got 1. So if we just change this a little bit in pre, I'll just show you that. It should do as I explained. There we are, it starts at 1 and then goes to 2 and so on. So the great thing about this is if you ever need to find something, you can grab this ID and store it somewhere in your software and be like, okay, keep track of this object. Someday we need to find this ID, something like that. And if your program is set to run for a long time, you may occasionally want to purge and sync and kind of go through your IDs, see what's missing, get a total count, reassign them. You can do things like that, but it's all going to be magically contained within here since this is a static declared in a CPP file. We're not going to get into that, but that's a theory of a thing you can do because, of course, unsigned int has a cap number once you get to, I don't know, what is it, some billion. There we go. There's the unsigned int max. So million, billion, yeah, about 4 billion. So you'll be able to have a maximum of 4,290 something unique instances, which should be plenty. But keep in mind that if this goes past that, it's going to start over at 0 again. So you probably want to have some logic when you get close to this cap. Now, obviously, you might think, oh, I'm never going to get to that cap. But when you're in something that's just running nonstop and is always using unique IDs, it can get to that. So you want to have some logic in here that will say something like, you've reached the maximum number, or maybe you'll have a cleanup function that takes some time to go through them all and resort them out and like figure out which numbers are missing. And you can essentially start to do some sort of hashing with these IDs. This is just a very simplistic example. Hope that all makes sense, but it's very important to realize stuff like that when you're programming or you're going to run into strange bugs. Okay, so back to the pure virtual thing I was talking about. You basically want to put any kind of function here that is purely virtual. So it needs to be virtual, and you got to give it a name. Say, we'll call it, let me think of something here. Okay, well, I was kind of thinking, every living being's got a cycle of some sort that it goes through for its life. So we could put that in here. I'm going to call that just update, and I'm going to set it equal to 0. So we now have a virtual, oh, void, it doesn't return anything. Void update equals 0. Now what this equals 0 means is it means there's no base version of it. Without the equals 0, it's going to ask us to instantiate and put our root thing. So if it's a living being, you're going to have to, if you're instantiating one, you're going to have to say how it updates, because the default is, well, you don't know. Maybe it's like a clam and it doesn't do anything but sit there most of the time and occasionally move. Or maybe it's something more active like a frog, where it's going to scan its environment and think about what it wants to do next. So this is where you could essentially, for this sort of example anyway, put some sort of logic. But if you set it equal to 0, then what you want to do is, well, let's show this first. Now that it's equal to 0, it's going to say, yeah, you're not allowed to instantiate this. And if you hover over it, it's going to give you some info. It's one of the great things about using an editor like this when you're new, is you can get some info right in line here. And it'll say it's an abstract class, has a pure virtual function. So we can no longer do that. And I'm not sure why it doesn't like that. Oh, it doesn't like frog now. So let's get rid of this one. This one's not going to work now. You can no longer instantiate living beings on their own. It's pure virtual, only for inheritance, often called an interface class. Okay, so now frog is missing some stuff. So basically we want to implement the pure virtual functions from anything we are inheriting from. So we're going to do some quick refactoring, and it does have, Visual Studio has a nice little thing here where you can implement, and it says operation failed. Okay. Guess it doesn't work that well. So basically we want to take this and paste it over here. This time without the equal 0. This time with override. Now I think override might be optional here, since you have to override it. But now let's go ahead and make this function. And it looks like it's seeing that frog is not in the project for some reason. I don't know. The Visual Studio helper thing is messing up a little bit. So we're just going to add this as we need. Maybe it doesn't like the word override. Let's check. So you can kind of play around here a little bit, and sometimes this will get you along. But oftentimes what you find out is that you need the function signature was, okay, that's weird. Override. Okay, let's put override back in there. Doesn't seem to matter. And there's update. It did put it in, I guess it just can't find this file for some reason. I'm not sure why. Visual Studio thing, sometimes it takes a little time for it to sort itself out. So now we can say what a frog does on its update. And we might need more info. Like, we don't have any info about the world or anything currently, so we don't know what a frog is doing. But we can assume that the frog is growing, gaining hit points, sleeping, or maybe it's dead. Who knows? Who knows? Poor froggy. So we could do something like, well, every update, let's get a status update. We'll say like if hit points is less than 0, then we are going to set its hit points to 0, so we don't want to go into the negatives. And maybe we want to do more stuff than that too. I guess it would be a less than or equal to 0. So we don't want it to go into the negative hit points. Maybe you allow negative hit points, but I'm in particular not allowing them. So if hit points is less than or equal to 0, well, make sure it's exactly 0. And then we're going to do something like we could, well, this was going to require us adding more functionality, of course, but we could say, we could put it on a dead list, for example, like the poor frog is dead. Maybe we want to say, we want to have a status over here, or maybe we know the status based on the hit points. So use your own discretion about what you want to do here, but we could at least do that. We could at least make sure, and maybe later we want to check. I guess this might be, this is kind of a weird thing to put here, to be honest, but just with the little amount of info we have, I feel like we're not gonna be able to do much. So now what you want to do is you want to start some kind of loop. So we'll say something like, well, this would be a game loop in theory. Frog.hitpoints is greater than 0. Well, you want to check it. So we'll go like frog.update. And then we would probably have something like simulation.run that takes in, well, simulation.update. So we, in theory, need some kind of simulation for this to do more. But what this would do is it would just sit here at this while loop waiting for this frog to go to 0 hit points. So what we might want to do is apply some logic there. We could We could do a lot of things. We could take in a few new functions. We could put some functions into our interface class. Like, well, first of all, we have this info that we're using for the struct. So maybe we want to start specifying some default hit points. So we could do that. We could go standard, or well, int hit points, or let's keep our syntax going. Hit points, and I guess that's it. We just got those two right now. And I'm going to show you a few more things here shortly. Hope you're sticking with this, learning something from this about inheritance a bit and C++ a bit. Okay, so now we have another thing added to that info that we could set. We can say hit points and give it some hit points. We'll say it starts with 3 hit points. Okay, now when we hit play, we'll see that it's HP still 1. Oops. Okay, so the problem here is I believe we haven't actually changed our constructor. We haven't set it here. We haven't said hit points equals info dot hit points. So a little bit of legwork, but what you can actually do here is you can go further with it, and you could make this even set its own struct to itself. So we could do something like, okay, well, we got living being info. Now, instead of keeping all these individually, we could just say we have living being info, and we can have info. Let's just keep it that for now. So now, in this constructor, rather than adding things to it every time, we can just say that info, what we named it, just capital info, equals the info that we're bringing in. And it should get all of those values. We got an error that it doesn't like. It says it doesn't have these. That's because they're now hidden behind the info struct, which we'll just have to add here. And it doesn't like it here, of course. And it's still saying it doesn't have hit points. So let's keep digging in. Info, oh, the hit points are lowercase now. We'll leave it like that. We just need to make sure we're calling it correctly. So species underscore name and hit points. And we might have one other function, correct? But use your discretion how you want to name your stuff. I'm just kind of winging it here. Of course, this one is now info.hitPoints. Info.hitPoints. Very well. There, we got 3 HP, and it's waiting for updates. So it's just sitting in that while loop, checking the old thing. So that's a decent amount about this. Now, if you want to not have this be an interface, all you got to do is remove the 0 and give a base instantiation. So in theory, we might want a base instantiation of update. Let's just show that real quick. Maybe we want to say info. We'll do the hit point thing. Like maybe we want to do that with everything, no matter what. We always want things to have some sort of hit points. So we have a default instantiation of checking the hit points and setting them to 0 if they're below 0. That way, when we maybe check this at the end of our main or end of a frame or something, and we like maybe clean up all the stuff that's dead or process an animation if they're dead or a thing, some command, maybe an audio trigger of their sound, we do that. But now we still have this update over here. We've removed the stuff. It should in theory no longer be checking, but you can force it to check by going living being update. And then it's going to call that base class 1 and then whatever special stuff you have for your class. Now, since we no longer have any pure virtual functions, this can be instantiated on its own again. So you got to be careful about that. There might be more or less you want to do. You kind of have to make the best decision for what you're doing. But we could say here at this point that, hey, frog is final. If you're going to use a frog, you can't inherit any further. So you just have to give it the proper being info. And you can use that class type grabber to see what kind of class it is. Class frog. So you can use that for comparisons if you want to know if they're the same type. But it gets trickier because you might be saying, okay, well, we're kind of going to know if they're the same type, right? Well. This is where things get funny. All right, so forget about this frog for a second. Well, let's make yet another type of living being. And I'm going to show you some more examples. New file, and rather than a frog, this time we're going to have a cat. Or let's do a lion. I like the idea of making a lion. So pragma once class lion with public living being. Yeah, and public private. So we don't actually need to give it anything here. Well, other than this constructor right here, we have to give it this constructor so that we can pass it along. So we'll put that in here. but of course it's lion this time. And we just need to instantiate it. Oh, we need to make that file, new file, lion.cpp, include our lion. Yep, I'm going to use quotes here. Fill out this function. Doesn't know what this info is. So yeah, we do have to include the living being class, which it doesn't seem to want to do through the helper. So just manually type it in here, and it should sort those out as soon as it is happy enough to do so. You can always hit this pure virtuals if you want to do the shortcut, but there are no pure virtuals because our update is no longer pure virtual. But you can go further. You can have plenty more functions, as many as you need, and some of them might not ever have a root case. So in that case, you would start making this a pure virtual. The way I'm kind of thinking about this, I would want this to be pure virtual, but maybe it's an unknown being. So, you know, maybe you don't want to have a special one of these. Okay, so now at this point, we would have some other kind of living being info. Let's do the lion info. And we could kind of hold like the lion's stats here, so to speak. And we'll just call this Sahara. I don't know all the lion types, but let's say they start with 10 hit points. All right, cool. So we'll make one. I'm just going to copy this. I'm going to change everything. This is now going to be lion, lion, and lion info. Lion, put all that in there. Doesn't know what lion is. Let's add it here. Oh, there we go. Now we should be able to hit play. Looks like we have an error. Let's take a look. Lions don't have jump power. I guess in theory, maybe we'll have something else. So we'll give the lion something else. Like maybe it has, well, frogs can't do much but jump. They don't have much of an attack, but lions definitely have an attack, and they have potentially a bunch of stats other than just hit points. So maybe we'll have a specific lion stat called like bite power. Oh, all right, bite power. However you want to do it. I'll do it like this. Handle case for now. Now I've got kind of a mix of these, but you know, I'm kind of adjusting on the fly here. Okay, so maybe we have bite power, and we didn't give it a base, so it should initialize to 0. Should just say 0. And looks like we forgot to call the living being function here in this constructor. So we will do that, living being, pass that info, and that's it. So you should get nice little warnings. And as you can see, since we didn't specify the lion stuff, it's got some weird numbers. Let's make sure we instantiate those properly, and that should fix it. Oh, we're setting frog info to different stuff. So this all needs to be lion info, clearly. So the default values it was getting for that struct was junk. So that's interesting. If we don't want it to do that, you can put stuff like this on these, and they will default to whatever your compiler wants them to be. Looks like our jump power is still very weird. So we want to go back to here. Oh, we haven't set it. That's why. See, with the frog, did we set the jump power? Yeah, it's got a default constructor. On this, we don't. We maybe want to say they're at least by power of 3. So that would give it the default, and there it is, 3. Now, if you don't want to give it the default, or you can still leave that there, but you could update it before you actually use it by just saying, hey, my lion. So after you've instantiated it, you can go lion bite power equals whatever you want. I'd say it's 10. And let's give this frog some jump power. And we'll make it a 2. So now we should see the updated stuff. I forgot to update the text here. I should say bite for the lion. There we go. So now we have some kind of basic stats that we can pull from and do things with, because we also could put in here, we could put in some functions to have these things take damage. We could say, I don't know, for example, virtual void take damage. Or, you know, this could be anything. This could be like maybe something the update will call. And if we want to say, well, let's go with eat. All right, and we're going to override this. So when we eat, we're going to think about, well, what kind of properties do you need to know about when you process and eat, right? So maybe we'll have another struct that we need to know about for every living being. So we'll put it here called food info, right? We'll keep it really simple. We could have all kinds of special foods and types and fill this out whatever you want. But maybe we'll just say like float carbs. All right, well, we'll stick with integers here. So you eat food, it has some amount of carbs or energy or something. We'll call it energy. We'll just keep it super simple. So we could say by default, maybe, well, let's not make this pure virtual. I don't think it's going to be necessary. We could say by default, hit points plus equals energy. So we could just straight up heal from this, right? But I guess it would, we'd have to have it in here. Maybe you'd have something like, well, you need to pass it. Let's do a pass here. So you pass in let's see, const food info, f-info. We'll do f-info. So now in this function, when you create it, let's get rid of the old one here. Probably going to do the same thing. We can say info.hitpoints plus equals f-info.energy. Hit points lowercase. Okay, so very good. Now, whenever you process and eat, hit points are going to go up by whatever energy. Now, you could, of course, if you're doing delta time, you can do heals over time and stuff with this, or you do all sorts of interesting processing. But the point is here, say we've got, well, this is hit points. We haven't specified a max hit points, which obviously you'd want in this case. But for example, let's just go lion.eat, and we need some food info here. So we could go food info. F-info. Maybe we could say he's going to eat a piece of meat. We'll just call it meat info, and we'll just give meat info dot energy a value of 2. I believe I made these integers, so we might want to always use floats or always use integers, just depending on how our program is. But now we can pass meat info into here, and he's going to eat that, and it's going to process. So we should see that he has the base hit points of even higher, because if we look at this, or let's see, what did we give it? We gave it the base hit points of 10. So after eating something with energy of 1, it should have a base hit points of 11. And we should say here, let's go ahead and hit play. And there it is, HP 11. All right, now I just want to show you one last thing. This gets pretty long. There's like so many things about this. Don't worry, I will drop resources here in a second where you can learn more about these. I just wanted to show you some logical examples, but I do have one more important thing to show you. So maybe every frame we want to do with these updates, of course, right? Makes sense. And maybe this food and eat thing would happen somewhere as part of your game. So in this lion, we do also want to make sure, well, we haven't specified our own specific update. We don't actually need one here anymore either, since we're not doing anything special. So we could get rid of that, and it would still call just fine, because it's inherited through the living being here. If this were pure virtual, once again, you would need to. And yeah, that's the only difference with pure virtual. There's more tricks to pure virtual than I'm not mentioning, I will say. All right, so the final thing I want to show you is I want to show you that what if you just want to like hold all of these in an array? Well, they have one thing in common, and that's that they're all of the living being type, frog, lion. Because, for example, we could make a vector of frogs, but we can't put lions on there. But if we wanted to put like all animals or all living beings on there, we could put this, make this vector a living being. And we'll just call this all beings. So we can kind of keep track of all of them. Doesn't know what vector is. Naturally, we do have to include that. So we're going to go include vector in our header here. And I think we're good to hit play right now, but we're not using this all beings yet. It's just blank, right? Let's initialize it. Might as well. So rather than doing all of this, a bunch of different text, this would actually work again right now unless we make it pure virtual. And it's got some errors in it though, but we'll just leave it. We'll just delete it. Okay, so what if you just want to be able to like iterate through and call all your stuff? We need a different case here really, so let's just keep it going. Yeah, I guess we could have, yeah, we'll do while one, because maybe we'll have like a break where we can get out of this if something specific happens. So while one is kind of okay, as we'll see here shortly. All right, so very good. So maybe you just want to do all beans dot pushback, and then we can do frog info, right? Then we can actually get rid of all this. And we can do the same thing for our lion. Rather than instantiating a lion right here, we could say all beans pushback lion. Now also, these are going to stay to the end of scope, so it might actually make sense to put them in each in their own scope, because you don't necessarily want this struct to sit around in memory once you've populated the info, right? So we'll let it do its thing, and there we go. So now what we can do, we'll just get rid of all this. We haven't messed with the byte power or anything like that, but you could, because you can go all beans, the one that just got pushed back would be dot back, and then we can go dot eat or whatever we want. Give it some food info there. Let's do this one here. Let's make that food info real quick, and we'll say eat. Give it meat info, and boom, it'll have done it. But also do the same thing here for the frog if we want to process anything before moving on. Beans.back, and we could say, this is probably going to be an error. I think I actually mean in place back here, but we'll write it out and see what it does, okay? What do we got? We got some options here. We can have it, well, you see the thing that's tricky here is we're only getting the options from the living bean. We're not getting the frog info, although it is a frog. Okay, so what actually we need to do here is specify that we're creating a frog in this one, specify that we're creating a lion in this one. We don't even necessarily need to give these structs different names now that they're in different scopes, but we should anyway, just for shadowing, to avoid shadowing as much as possible. Okay, so now we'll have a frog here, a lion here. So this frog we should be able to call, I don't know if the syntax has picked up on this yet, but we should now be able to call the frog info on this particular one. Back dot, what does frog have that we can use? Jump power. So let's attempt, even though it doesn't say it, set jump power equal to 2.f. As you can see, it doesn't like it. So let's hit play here. But we do know that we're pushing a frog onto that. And now this is where we can get a little tricky. Frog undeclared. Oh, we got some errors here. Let's just get rid of that. Let's just comment out this whole thing. I will fix that up shortly. Just don't want it to get in the way. But what we can do, we can just go through all these. We can go for each const auto by ref. We don't want to change them. We just want to look at them here. We're going to say LB, which will be a living bean, out of our all beans, or maybe we'll just call it a B. Keep it super simple here. We could say, I don't know, let's just do a little C out. Basically all this info, right? Why not? But now, rather than doing this every time, we can go whatever the type ID of B is here, and all down the line, just all the B stuff. It's not going to know about jump power because we are once again looking at all beans. So this is where it can get a little tricky. But this is also where the interface comes into play. As you can see now, it is pretty much working properly, except the type is living bean no matter what it is. So how do we tell which type it is with this sort of thing? Well, there might be some really fancy way of doing it, but one really easy way to do it is to just turn this back into a pure virtual and say, look, you got to implement your type name of some sort. Or you've got to implement this type name. So in any of these, we can instantiate them by going implement pure virtuals, and we're going to say, well, the lion type name is going to return type ID of itself. Might be star this. It's one of these. I don't know. We'll find it here. Or actually, I think I might need to have type info in here. Type info, or maybe we could just have this somewhere else. But we essentially could override it. Yeah, there we go. And let's see if this works. This might be a compiler error, but now when we call type name, we'll have to use our own function rather than this. We'll go with type name, and we pass in itself. Type name is unidentified. Oh, it's b.type name. I don't think we need to pass in anything there. This isn't going to work for all beans necessarily because they're not all instantiated. So we're going to have to add it for frog, implement the pure virtuals, type ID of this dot name, and I think we've also got to add type info here. So we probably just want, if you know you're going to do it the type info way, you could just add it to the living bean type info. There might be a better way of doing this. I'm sure there is, but it involves a lot more code. So I'm kind of doing it in like the least code amount of way. And we have some errors. So we can say, okay, what's the problem? Doesn't like the pointer to this being a reference. So I think we just have to dereference on this with star this maybe. I think that's right. And it looks like it put these in private. These should not be private. That's just the way Visual Studio decided to do it. So let's go like that, and we still have one little problem. Cannot convert this pointer from const living bean to living bean reference. So the thing about starting to make one thing pure virtual is the whole class becomes pure virtual. So anything we previously instantiated that we wanted to have default behavior will no longer work. So we do have to make some choices here about how we want to do this. And I think kind of the most obvious way with this type name thing is, well, we want to have a default behavior, right? So let's give it a default behavior here. And maybe we can just return the whole type ID of itself. And this should probably be a string. Let's see if that works. Or we could just do it encapsulated as a string like that. It's a bit ugly, but we will see if that works as a default behavior, so that if we don't override it in these classes, it should give us the root type. All right, everything looks good. We have the same thing. Let's see. We still get the root type, or if we get errors. We get errors. Okay, so what do we get here? Doesn't like this type name that I have. Oh, I need to. Oh, there we go. We're not currently overriding them. And now it builds, and it looks like we get class with a const pointer 64, which looks a little weird because we are not dereferencing this. So it is literally getting the pointer to the class. It's getting the type ID of the pointer. So maybe we want to dereference this, which is just its class, and we should get class living bean. So if we want to override this behavior in each of these, we can get their type. So let's do that. Let's start with the lion, and maybe even the frog, and we will override this behavior. Essentially doing the same thing. Well, let's see here. Uncomment that one. Put this in here. Make sure we have it declared here. And we'll do the same thing with frog. Uncomment this line. And put this in here. And now, what do you think is going to happen when we go through all the beans and spit out the type info? Is it going to call the root class? Is it going to call the one that we actually pushed back? Let's find out. It looks like it calls the root class still. So how do we get it to properly use this override of the one we declared? Because in theory, it should be. Let's take a look. This is an area where pointers can help us out. So instead of just storing the objects of living beans, we're going to store pointers to living beans. So I've added a star here. And now when we push back a new type, like the new frog here and the new lion here, we want to make sure we use the new keyword so that we're creating a new object. Now keep in mind that you're getting into memory management at this point, so that is something to consider. It might even be better to make these some other kind of smart pointer if you want, but you'll have to do that at your own discretion. We're going to kind of leave off about here anyway because we're getting to the end of the points. All right, so we push back pointers to our new objects, and of course when we call the back functions that we were calling before, we need to use the pointer, but now you'll see that we're now allowed to access, it should access jump power in the frog. Do we have that still? Yeah, we have that here. Oh, let's go back here. Living bean has no, okay, so it's still seeing it there. Interesting. Okay, I guess we have to do it slightly different, but you can see that when we get a reference to it and do the type name here, it's now going to call the class that it has instantiated as, and not the root class anymore. So that is pretty interesting. So as you see, we have defined some default behavior here, because we kind of have to, since this isn't pure virtual. And if we end up using it, we can just override it and call our own version of it, and it's going to call this own version of it. So that's the difference. You basically just need to store vectors of pointers if you want to make sure you're using the overridden class, which is kind of interesting if you think about it, because maybe we want to override more stuff like that eat function. We can. And if this is not a vector of pointers, void eat, or just override. Let me see how I had it here. Oh, we need food info, of course. Let's just copy this whole thing over. Now let's override. So we have default behavior, of course, but maybe we want to have lion behavior too, where you check the type of food you eat or something, or maybe lions are super efficient at eating, so their hit points is going to be a bigger factor. We need info dot hit points. That's what it is, right? Just thinking for a minute. Maybe we'll do like plus equals finfo, put it in parentheses here, because I'm going to do a little math, dot energy, or maybe they're less efficient. So we add to their hit points the efficiency, but only times 0.90 or something. So maybe we could add that to their hit points, but also we only want to add integers, so we want to round this off. So the easiest way to do that would be to static cast to an integer, and boom, there we go. This is a little risky doing this whole static cast thing in this way, but that just says, hey, it's going to round it basically, and this is probably going to round up, but if energy were huge, it might cut off a few ticks. So it can matter a little bit, and there we go. We'll see that the lion didn't actually end up gaining any HP because it wasn't enough to get to 1. I guess it's rounding down. I guess we need some math functions. This might always round down. There's one way I guess we could check. Let's see, we're given its energy 1. What if we give it 2? Then does it round down to 1 and we end up with 11 hit points? Yes. So that 0.90 is going to round down. And there's a lot of little theory you could bring in. You could say, hey man, what if we just want our hit points to be floats instead so we can be more precise? Or something like that. Or what if we don't want to ever do this sort of behavior in general? Maybe it's just something to avoid. Maybe we could just do more flat out amounts like times 2. Spell energy right. There we go. And that would give him 4 hit points. So you kind of just got to decide on your types is the point there. But I think I've showed enough about polymorphism. And well, yeah, I did end up talking about a little bit of polymorphism. This little concept here, where we can instantiate types with a subclass as pointers, is called polymorphism, and there's more about that. All right, I'm going to show you some quick links about where you can, the best sources I think to learn more about this. Okay, bright screen alert. Now, first of all, I will say that I did do a fair amount of Googling and Stack Overflowing and stuff like that, just even in this little project. And that's always a thing. You're always going to need to look up stuff unless you're like a master. And for something like C++, it takes a really, really, really long time, or just a lot of practice to get to master. So bright screen warning. I'm going to be bringing over a bright screen. All right. Sorry about your eyes. This site, en.cp reference, is one of the best. So we would just want to look up inheritance, and we'll see inheritance C++. They've got a bit of a book intro, and you can learn all about it here. And there's a lot of examples. I really like this site for looking up stuff. It's like they have some derived class info, which will give you even more info. And if you in general have any major questions about C++ or want to look for some documentation, I like this page. You can also look at specific versions of C++. And if you look at anything in particular, you can switch between different versions, tells you which headers to find in. This is kind of the definitive site for learning this stuff. Let's look at a quick polymorphism, and we'll see that they have a book. I didn't know about this book thing. That's new. So that could be really handy. If you want to get ahead, just go through that book. But what I've noticed personally is it's really hard to read just this dry info about this kind of stuff sometimes. So it often helps to have a bit of a project and then look at it from there. Well, this site isn't so much to teach. It's more of a reference guide. So there might be better for teaching. But if you have any questions about any of this stuff, you can type it in here. So for example, what if we type in type ID? So we want to learn more about that. We can go look at the type ID operator and see how it works. Another thing you can also do for the type ID operator is you can just type it in and see what happens, basically. So, okay, let's go here. We got type ID right here. Let's go follow, which I believe is F12. There might be an option with the right click. I'm not sure. I'm not seeing it here. But peak header. Okay, so we want to, if we do like peak header here, I think. No, it's not it. Yeah, that's not it either. Okay, so I guess it's just F12. F12 kind of follows the code. So if you put your cursor on it and press F12, there might be a better way. Leave a comment for sure. You can often go to it, but we can't go to this one because it's in the standard template header. So what we want to do is go to this header, and you can press F12 on these standard header. It doesn't seem to like to follow this one. Let's see if we can follow a string. Yeah, we can follow a string. I'm not sure why it's not wanting to follow that. It generally should, as long as it's illegal. Header, type info, not found in our current paths. So let's look again, see if we can find out anything. All right, type ID operator, type ID with an expression. All right, very good. And it should say what header it's defined in. It doesn't really say here. Header type info. Okay, part of the type support. Finish type info. Yeah, I mean, earlier I was able to go into this. So I think this right now is just a bug with Visual Studio. You should be able to follow it. I was definitely looking at it earlier. So Visual Studio is a little awkward sometimes with the way it tries to help you. You know, it's a love-hate relationship. It's better to at least have the option, at least most of the time when it's working properly, than not. Because as you've seen with all the squiggling and stuff, most of the time they've been pretty accurate. All right, I hope this helps you understand inheritance a lot more. And I would say just practice. Do something like this with a main. Play around and kind of see what you can do. See if you can get your things to work. This is something that's done all the time in a lot of different software, especially games and stuff. Yeah, just being able to derive types is something that can really scale ahead some of the things you can accomplish with programming. But definitely good to know. All right, I'll see you in the next one. Hopefully you guys found this helpful. Matt from Code Tech Tutorials, over and out. And if you want a lot more episodes like this and want me to keep making them, consider signing up over on my Patreon page or supporting somehow. Even just leaving a like or a comment helps a ton. But yeah, the more support I can get, the more I'll do stuff like this. Thanks, guys. See you in the next episode. Peace out.